Hello and welcome to 12.9 Combinations. We talked last time about permutations, now we're talking combinations. Combinations, a distinct group or set of objects without regard to their arrangement. The order doesn't matter. The first one chosen, last one chosen, we don't keep track of that. We just want to know what the group looks like. So these are combinations. The formula for combination: the number of combinations possible when R objects are selected from N objects is found by NCR, which, so that part right there looks just like the permutation formula. So it's N factorial over N minus R factorial. Then we divide by R factorial. This takes out which one came first. So we're going to evaluate the following. So I just want to say here, note that NPR was N factorial over N minus R factorial. Okay, evaluate the expression 8 choose 2. That's going to be 8 factorial over 8 minus 2 factorial times 2 factorial. So 8 choose, we'll call this choose. 8 choose 2 with a C. So it's going to be 8 factorial over 6 factorial times 2 factorial. That would be 8 times 7 times 6 factorial over 6 factorial times 2 times 1. With that, the 6's will divide out, and 2 goes in 8 4 times. And we're left with 4 times 7 is 28 over 1, which is 28. Now your calculators will have this button too. If it has the P, it's going to have the C. 8P2 is going to be 8 factorial over 8 minus 2 factorial. That's 8 factorial over 6 factorial. That is 8 times 7 times 6 factorial over 6 factorial. That's 56. Because order was important in this second case, order is not important here, which is, A than B is the same as B than A. Over here, A than B is different than B than A. 12 choose 8 is going to be 12 factorial over 12 minus 8 factorial times 8 factorial. That's 12 factorial over 4 factorial times 8 factorial. 12 times 11 times 10 times 9 times 8 factorial over 4 times 3 times 2 times 1 times 8 factorial. So the 8 factorials will divide out. 4 goes into 12 3 times, 3 goes into 3 1 time, and you can say 2 goes into 10 5 times. So what's left is 11 times 5 times 9. That's 495 over 1, which is 495. Whereas 12P8 is going to be 12 factorial over 12 minus 8 factorial. It's going to be a much bigger number. 12 factorial over 4 factorial. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 4 times, 6 times 5 times 4 factorial over 4 factorial. And that number, ready for this? 19,958,400. Woo! So you can see 12 choose 8 versus 12 P8, two vastly different numbers there. Example 2, an ice cream parlor has 20 different flavors. Cynthia orders a banana split and has to select 3 different flavors. How many different selections are possible? Well, that's 20, choose 3. She doesn't care which one she got first. If she got peanuts before the hot fudge on there or the cherry, whatever, it's all good. So that's going to be 20 choose 3. Put that in the machine, that's 1140. I'm going to go on to page 2 here and clear the board. Rachel, Maria, Darlene, Jagdeep, Heidi, Samantha, Christy, Destiny, Katrina, and Stephanie. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's all girls. Decided to form a math club. Yeah, it's a good idea. They must elect a president, vice president, and a secretary. How many different arrangements can there be? 3 members get to go to a mathematical association of America meeting in San Francisco. How many different combinations are there? Okay, so for the first part, order matters. President, vice president, secretary, it matters who's in each position. It's not just saying 3 people to be leaders. So that would be 10p3. 10p3 is 720. In the second case, 3 people. It doesn't matter who they are. 3 people get to go to San Francisco for a conference. So that'd be 10 choose 3, because the order doesn't matter. It's not like you're the first, second, third. It's just you group of 3. And so in this, 120 different combinations. I'm going to move this up a little higher, so go ahead and pause if you need to. At a medical research center, an experimental drug is to be given to 16 people, 8 men, 8 women. If 14 men and 11 women have volunteered to be given the drug, at how many ways can the researcher choose the 16 people to be given the drug? So that's going to be 14 choose 8, that's the men part, times 11 choose 8 for the women part. That'd be 3,003 combinations for the men times 165 combinations for the women, or 495,495 combinations for the group. That'll do it. That is 12.9 combinations. I hope you enjoyed that. I sure did. And send me your questions. Thanks.